Greetings everyone. I hope you are all doing great. I'm Amit Saxena and I warmly welcome you to a brand new episode of Cybersecurity Beginner to Pro series. In this episode, which is episode number 5, I'll take you through the next cybersecurity threat, which is SQL injection. Please watch this video till the end so that you don't miss out on any important aspect. Okay, before I go ahead and discuss what is SQL injection, I'm assuming that you guys are aware of SQL language, which is database query language, and what is database. In case if you are not aware of SQL query and database concepts, just let me know in the comment section. I'll try to create a video, the basics of SQL and database for you guys. So just let me know. Okay, let's begin. Understanding SQL injection. SQL injection is one of the most critical and fascinating topics in web security. In simple terms, it happens when a hacker inserts malicious SQL code into a web application's input fields to access or modify database information. Websites often communicate with databases through SQL queries. For example, when you log into a website, your username and password are sent to the database through an SQL query that checks if your credentials are valid. However, if that website doesn't properly validate or clean the user's input, attackers can inject their own SQL code, which changes the behavior of query completely. This vulnerability has been around for decades and still ranks among the OWASP top 10 web application risks. It remains a major reason for large-scale data leaks, financial loss, and privacy breach. So let's start with this video. So today we are going to discuss what is SQL injection, how SQL injection works, SQL injections example, real world impact, anatomy of an SQL injection attack, types of SQL injection attacks, and tools and resources for learning. And finally, we will conclude with the lessons which we learned in this video. Okay, let's begin with what is SQL injection. Simply put, SQL injection is a cyber attack technique where an attacker inserts or injects malicious SQL code into an application's input fields so that database runs command the developer never intended. Let me go through the definition again. It is a cyber attack technique where an attacker inserts or injects malicious SQL code into an application's input fields so the database runs command the developer never intended. In more formal terms, SQL injection happens when user input is included in a database query without proper validation or separation, allowing the input to change the structure or behavior of the SQL command itself. Let's compare this with an analogy. Think of a website as a restaurant and the database as its kitchen. Normally, a customer's order, your user input, is safely passed to the kitchen and the chef follows the recipe. But if someone hides a secret instruction in that order, something like and also give me the master key, so the chef might follow it, not realizing it was a trick. That's the essence of SQL injection, data that pretends to be a command. SQL injection is one of the most common vulnerabilities in web security and it still appears in the OWASP top 10 risk list. It can affect small student projects and large enterprise applications alike. In this lesson, we will explore exactly how SQL injection works, examine real-world incidents, we will understand different types of attacks, and finally, we learn the key defenses and make code secure. Now that we understand what is SQL injection means, let's move on to see how it actually works. To understand SQL injection, let's break it down into clear steps. First one is vulnerable input, second is malicious code injection, and the last stage is exploitation. That is includes execution of that malicious code also. So we will start with vulnerable input first. A web application receives input from users through fields like login forms, search boxes, or URLs. If that input is directly added into a SQL query without validation, it becomes a target. Step 2. Malicious code injection. This one I am going to discuss in detail, and I'll also going to show some examples for your better understanding. In malicious code injection, the attacker enters harmful SQL commands. For instance, typing double quotes or 1 equals to 1 instead of a normal username. This small change alters the query's logic. This I'll show you in the example how the hackers are doing that. Okay. So let's jump on the examples. So example 1, authentication bypass. It's a classic example. Okay. So here payload is 1 equals to 1. Now what is payload? What does payload means? A payload is the actual piece of malicious code or input that the attacker sends to the system to exploit a vulnerability. So here payload is the actual piece of that malicious code. Okay, so we have taken the example of inquiry where we have taken select star from users where username equals to user input and password equals to password input. Now what does that query means? This is the original query which we have through which we have instructed this database. So here this query means give me every column from the users table for the record where the username equals what the user typed and the password equals what the user typed. So that is the meaning of this query. So this query is going to fetch the data based on the command given. Okay. Now after injection, so hacker injected 1:1 code or 1:1. Now the injected query becomes select star from users where username equals to or 1:1 and password equals to double quotes. Okay. So what will be the effect after the hacker injected the malicious code? Okay. The where clause is always true, allowing login without valid credentials. So here where clause becomes always true when we are using 1:1 in the original query. So this can let an attacker log in without credentials. So attackers don't need credentials if they are able to insert 1:1 in the original query. So that's how they inject malicious code. Now let's take, I hope you got that example. In case you are facing some, you are not able to contemplate or you are not able to understand this, let me know in the comment section. Okay, the next one is data extraction. Stat queries were allowed. Okay, here the payload or malicious code is select credit card from payments. Now the original query was select from users where ID equals to user input, which means show me all the information. So this is the command given to database where what we are seeking from database. Show me all the information about the user whose ID number matches what the user entered. So that's the interpretation of this query. Now after injection it will become select star from users where ID equals to double quote, select credit card from payments and double dash. So that's the malicious piece of code which hackers added. So how it is going to affect? If the database and driver allows tagged statements, the attacker appends a second query to read sensitive tables. Many modern DB drivers disable stacked queries to limit this risk. So if we are allowing stacked statement in our queries, then we are inviting the hackers to add malicious code. So there are certain things which we need to take care while writing queries. So that we are also going to discuss in the slide where we will be discussing how to prevent SQL injection. So you got this one. Okay, next is union based data extraction. So here the payload or the malicious code is union select username password from admin. So the original query is select name email from customers where ID equals to user input, which means show me the name and email address of the customer whose ID matches the value entered by the user. After injection, it will become select name email from customers where ID equals to union select username password from admin. So the entire payload is added after where ID, right? So the payload is added after the where ID. So it will become malicious now. So that's SQL injection. One more example of it. Okay, effect. How it is going to affect? It appends results from another table. The app may display unauthorized data. Works when query results are returned to the unit interface or UI. Next example is comment based truncation. Here the payload or malicious code which hackers used is admin a single quote double dash. Then the original query was select star from users where username equals to user input and active equals to 1. So what we are trying to fetch here from this query? So it means give me everything about the user whose username matches what was typed and whose account is marked active. So we are here looking for active accounts. Okay, after injection it will become select star from users where username equals to admin and active equals to 1. So here hackers replaced user input with admin double quote double dash. So admin double dash is payload or malicious piece of code. Now the effect of adding this payload in the original query is comments out the rest of the query, allowing bypass of conditions like active equals to 1. So it will also give you the data of accounts which are not active. So that is something which is not expected. We are only looking for the active accounts, but when it bypasses it, it will give you list of all the accounts, which is not permitted. So we need to be very careful while writing queries. Next example is numeric parameter injection. Okay, here the scenario is URL like product ID equals to 10 where ID is expected to be a number, and the malicious code is uh, 10 or 1 equals to 1, product ID equals to 10 or 1 equals to 1. So instead of 10, the payload says product ID equals to 10 or 1 equals to 1. Right? Now 1 is to, what will this 1 equals to 1 do? You will see. Resulting query will become select star from product where ID equals to 10 or 1 is to 1. What will be the effect? It returns all products, not just the one requested. Okay, so here we are requesting a product whose product ID equals to 10 in the original query, but after adding the payload, it means that everything, all the products, whether it's irrespective of the ID. So it will give the list of all the products which was not actually intended when we were writing that query. But after adding the payload, it will give all the list of products and reveal access data when input types are not strictly enforced. So this was the last example. I hope you get all these examples. Okay, the last step is exploitation. The manipulated query runs on the database since 1 is to 1 is always true. The system may think the login is valid and grant access. Through SQL injection, attackers can not only log in without authorization, but also read, change, or delete data from the database. Now that we understand how it works, let's look at real cases where this vulnerability caused major damage. Now let's check out some real world examples. Okay. SQL injection has been behind some of the biggest cyber attacks in history. In 2009, a hacker named Albert Gonzalez used SQL injection to hack Heartland payment systems, stealing over 130 million credit card numbers. This was one of the largest financial data breaches ever recorded. In 2008, more than 500,000 websites running Microsoft IIS were compromised through automated SQL injection attacks. Hackers used scripts to scan and exploit vulnerable websites without manual effort. These attacks had serious consequences: financial losses, customer data exposure, and loss of public trust. Companies faced lawsuits and long-term reputational damage. SQL injection can cause massive data leaks, permanent data destruction, regulatory fines for data protection failures, irreversible brand damage. Now the takeaway here is that even a small coding mistake can have a massive impact. That's why understanding this vulnerability is not just useful, it's essential for anyone who writes or maintains web applications. Next, let's analyze what actually happens inside an SQL injection attack and the various type attackers use. So let's see the anatomy of an SQL injection attack. An SQL injection attack usually follows 4 main stages. The first one is discovery. In discovery phase or discovery step, the attacker finds an input field or URL parameter that accepts data from the users. So that's the discovery part. Second is injection. Okay, when attacker has found an input field or URL parameter, the malicious SQL commands are inserted into that field. First, we found the field, then hackers inserted the malicious SQL command into that field, then execution. The web application sends the crafted query directly to the databases without any validation. That malicious query is sent to the database directly without any validation. Finally, the exploitation. The database executes those commands, revealing, altering, or deleting sensitive data. So there are also different type of SQL injection attacks. Okay, so that slide, I hope you got the 4 steps or 4 stages of SQL injection and finally exploitation. Now we will be discussing the types of SQL injection attacks. What are the different types? So the first one is classic or error-based injection. Here the attacker injects code and gets visible error messages or data from the database. This is the easiest to spot but also the most dangerous if error handling is weak. Next is union-based injection. Here attackers use the SQL union operator to combine results from multiple queries. This allows them to extract additional information from different tables within the database. Next is blind injection. In this type, the attackers can't see any direct output. Instead, they learn about the database by observing how the application responds. For example, by measuring response times or behavior changes. Blind injection is slower but extremely stealthy. It can take longer but still lead to complete data exposure. So these are the 3 types of SQL injection attacks. If you want, I can create a detailed video on all 3 types. So just let me know in the comment section. Now, let me go to the next slide. Okay. Is how to prevent SQL injection. Even though SQL injection is a powerful attack, the good news is that it is completely preventable with the right practices. Here are the key defense techniques every developer should follow. First one is use parameterized queries or prepared statements. This is the most effective protection. Prepared statements separate SQL code from user input, so no matter what is typed in the form, it is treated as data, not as executable SQL commands. Most programming languages support this, such as Java, Python, PHP, OPDO, and .NET. Next is input validation. Always check and sanitize what users type. For example, if a field expects a number, reject any text or symbols. Use allow list that define what is acceptable input. So while defining input validation, please be careful what is going in that field. It should be fixed and properly validated. Now, third one is least privilege principle. Limit database permissions. The account user used by your web app should have only the minimum privileges needed. This way, even if it's exploited, the attacker can't access everything. So that is least privilege principle. Next is regular updates and patching. Keep your software libraries and frameworks updated. Many known vulnerabilities get fixed through patches, but only if you install them. So keep your software updated all the time. Okay. Next is tools and resources for learning. On this slide, we will cover the best safe places to practice and learn SQL injection. First, OWASP Juice Shop. And this is an intentionally vulnerable web application for learning. It offers challenges at different difficulty levels and a safe sandbox to try payloads and then patch the code that made the app vulnerable. This is the great starting point to learn. So OWASP Juice Shop is something which you can try try for testing and learning purpose. Next is SQLmap and Burp suite. Industry tools. These are industry tools. SQLmap automates detection and exploitation of SQLi in lab environments. It's useful to understand how automated scanners work, where Burp suite is a manual testing proxy, intercepts requests, modify inputs, craft payloads, and analyze responses. So these are the tools used for simulation, so that you can actually learn when you inject a SQL query or use a malicious piece of code or payload. So how the database react, and then how you can prevent it, so that you can learn when actually something happens or about to happen, you can prevent that. Okay, then interactive labs like PortSwigger Academy and HackTheBox. PortSwigger offers guided lessons that explain payloads and fixes step by step. HackTheBox gives CTF style challenges to level up your skills. A few best practice tips. Always use authorized environments like local VMs, lab instances, or platform sandboxes. Never test against live sites you don't own. So this is very important. Never test against live sites which you actually don't own. Second, start small. Practice classic payloads. First move to union and blind techniques, and always practice patching the vulnerable code afterwards. Next is keep a learning log. Record payloads, responses, and fixes. This helps build pattern recognition. So this will help you build a pattern recognition. Then learn responsibly. These tools teach attacker techniques so that you can better defend systems, not to cause harm. Combine these resources, build both offensive understanding and defensive skills, exactly what you need as a developer or security-minded student. Now the last one, here we will end our video. So the key takeaways. First one is SQL injection remains common but entirely preventable with proper coding. Knowledge is the defense. This is common for all kind of cybersecurity threats, whether it is phishing, cross-site scripting, man-in-the-middle attack, or this one, SQL injection, and others also. Okay, knowledge is defense. Learn attack methods to design better protection. So here you need to keep updating yourself with new attack methods and how to prevent them. Secure by default. Validate inputs, use prepared statements, and apply security from day one. The quick mantra would be write secure code from the start. Prevention beats remediation, because remediation costs a lot. Okay, now that you understand SQL injection, remember, knowledge is your strongest defense. Keep learning, keep practicing safely, and always code with security in mind. If you have liked this video, please like, share, and subscribe. Thanks for watching Understanding SQL Injection, a student's guide. See you in the next video, where we will explore more ways to protect your applications. Also watch this space for previous episodes if you have missed out. So see you in the next video. Bye for now.